Today, we're going to see how we can use Apache Spark within a Jupyter notebook and combine that with Python. When we combine Python with Spark, it's called Pyspark. First of all, you need to have Spark and Python installed on your computer. I mentioned that as a prerequisite. Next, you open your notebook and you create a Spark context. So we're going to import find Spark. This is going to find Spark within your system. And then we use the initialization function. That's find Spark.init. Now we import Pyspark. When you run this command, it's going to start Spark for you. From Pyspark, we need to import Spark context and Spark config. Now we can say conf is equal to Spark conf, the configurations, .setMaster is local. I have set it to the local drive. .setAppName, I've named it Pyspark, where sc is equal to Spark context of conf is equal to conf. We're naming the context sc for convenience. Now when you hit run, you will have a perfectly functional Pyspark notebook. Let's start by importing data. In Spark, we work with RDDs, or Resilient Distributed Data Sets. An RDD, Resilient Distributed Data Set, is a distributed collection of elements. Spark automatically distributes the data contained in RDDs across your cluster and parallelizes the operations you perform on them. RDDs support two types of operations: transformations, which create a new data set from an existing one, and actions, which return a value by performing a computation on the RDD. I'm going to start by reading in data from a file on my system. So I'm going to say A is equal to sc. We're calling the Spark context .text file because this is a CSV file. It can be read using the function .text file, and this is going to be saved as an RDD. When I hit run, my data is going to be stored as an RDD. Now we're going to check the number of elements within the RDD. So I'm going to say a.count. I'm using the count function, and when I hit run, I get 1001, which is exactly the number of elements in the RDD. Let's view the first few elements. We're going to use the a.take. In this case, I just want to see the first 5 elements, so I've entered 5. That's going to give me A, B, C, and D, and the first 5 elements within those 4 columns. Now let's talk about transformations. Let's take a sample array named data, and we're going to say the elements are 1, 2, 3, 4, and 5. Filter transformation. This transformation can be applied to RDDs in order to keep just the elements that satisfy a certain condition. More concretely, a function is evaluated on every element in the original RDD. The new resulting RDD will contain just those elements that make the function return true. Let's take an example, dist data. First, we're going to parallelize it, and then we're going to pass the data variable. Now we're going to say b is equal to dist data dot filter lambda x, where x modulus 2 is equal to 0. So this is where the filter is applied, and the condition is that x must be even. So when it is divided by 2, the remainder should be 0. Once this filter is applied and you hit run, you can check the elements in the new RDD by using the take function. So b.take, and we're going to check the first 5 elements. It turns out that only 2 and 4 satisfy the condition, and these have formed the new RDD. Map transformation. Here, in this type of transformation, every element is checked, but a boolean is returned for each element. So we will get an array of booleans, meaning either true or false. We're directly going to use b is equal to distdata.map. This is the map transformation function, where lambda of x and x modulus 2 is equal to 0. Again, we're saying that the condition is for x to be an even number. Let's take a look at the new RDD by using b.take and passing 5. This time our output is false, true, false, true, false, because 1 is odd, 2 is even, 3 is odd, 4 is even, and 5 is odd. So that is 3 false values and 2 true values. Now that we've finished with transformations, let's move on to actions. The first action we're going to use is the reduce action. First, we're going to create an RDD. Let's name it num_RDD, then sc.parallelize, and we're going to give it a range, which is between 1 to 1000. Now let's use the reduce action. So that's num_RDD dot reduce lambda x, comma y of x plus y, and that's going to give us the output 4995 500. By saying x plus y, we have reduced num RDD by adding all of the elements between 1 and 1000. Now let's count the total number of elements. So we're going to use the count action. Num RDD.count will give us 999 because that's exactly the number of elements between 1 and 1000. Let's find the maximum number. So that's num RDD.max, which gives us 999 once again because this is the maximum number. To find the minimum number, we use the find minimum action, which is num underscore RDD.min and gives us 1. Let's find the sum of all the elements in num RDD. So that's num RDD.sum, which gives us 499500. The variance action will find the variance of num RDD. So that's num RDD.variance, and that gives us 83166.666 and so on. The standard deviation action will find the standard deviation, just as the name suggests. So we say num RDD.stdev, and that gives us 288.3863 and so on. This covers the basics of Pyspark in Jupyter Notebooks. You can practice some more on your own, and in the next video we'll be talking about basic commands using RDDs.